Hello everyone, welcome to the e-lecture series on subject power quality. I am Mr. Harpe Somnath, working as a assistant professor in electrical engineering department of Matosri College of Engineering and Research Center Nasik. This course is specially designed for the last year students of B Electrical Engineering, Savitribai Phule, Pune University, Pune. So let's move towards the actual course content. Now, before going into the depth of the course, we need to understand the need of the power quality. So now, while studying the power quality, we need to understand basically what exactly the quality of anything that we normally consume in our day-to-day life. Suppose here you can see on a slide the picture of a water purifier. We all know that a water connection is available in our house, but still we do not drink it directly. We filter it before drinking because there might be any mud particle, any impurities, any germs in it, which may causes the illness. Similarly, in the power system also, due to the various non-linear loads such as power rectifiers, then inverters, due to those load what happen, the original form of sinusoidal waveform of voltage or current may get disturbed. So here we can see this is the another waveform where we can see that one waveform here it is of the nature with a very ideal sinusoidal waveform. Other one is the waveform with the distortion. Now what happened? It is because of the non-linear loads into the system which causes the disturbance to the original sinusoidal form of the load. And this particular subject, it is all about the study of the power quality that is we are getting for our load. Now moving ahead, we need to know how exactly we can define the good power quality. So here there are some criteria that power should fulfill before actually consumed by the load. In that, if voltage has a constant sine wave shape with the fundamental frequency that is 50 Hz. The fundamental frequency for India it is of standard 50 Hz frequency. Another criteria is it forms a symmetrical three-phase power system. So next characteristic is it should be unaffected by the load changes. Means whenever any particular load consumes a voltage, at that time whatever the current he may draw, voltage should not change. It should maintain its standard value. Next thing, it is reliable and energy available when it is required. Means what? That whatever the our requirement at that time, your supply must be there. So these are the some, we can say that the characteristics of the good power quality. So let's see what exactly the nonlinear load into the power system. Why they are in a system? As they are creating a problem into the system, but still there are certain loads which we cannot avoid from the power system. So these loads are normally the AC drives, then processor based power controllers in various industries like rectifier, inverters. Okay, so these are such a loads which we cannot avoid, and these are the loads which causes the power quality problems. Now here if you observe, there is one voltage source, then one transformer is there, it is utility side transformer, another transformer too, it is from the distribution side. One common point is considered here, that is the point of common coupling. It has some significance while studying the power quality. Then one load is connected, that is load A, which is also called the polluting load. Why it is called polluting load? Because due to this load, particularly the load B is getting affected, or we can say that the A load is the culprit into the system which creates the non-sinusoidal waveforms into the system which may be consumed by the load B, and due to that B load may be affected. So here there are we can say that load A is nothing but the non-linear load and load B is nothing but the linear load. So let's understand first what exactly the non-linear load. So the non-linear load which is not drawing current in proportion with the supply voltage, that is nothing but the SCR based AC to DC converters. Now these converters using the power electronic devices like SCR, then or we can say that the current controlling devices. So these particular devices are not drawing the current in proportion with their supply voltage. Here we can see that VI characteristics of SCR. So if we consider the operational quadrant of a SCR, that is where it is into the forward bias condition. So here initially when we rise a voltage up to the breakpoint voltage, current is very less. We can say it is a leakage current. And once SCR get triggered, the on-state voltage becomes very low. It is less than 2 volt, and current is rises suddenly. And we can say that the nature of operation of SCR from its input voltage to the output current, it is not in proportional to each other. That's why every load which contains power electronic devices are called the nonlinear loads. Now, so how they affect onto the system? So when we say that load A is taking a supply which is non-proportional to the supply voltage, so obviously whatever the remaining shape of waveform, it is inserted into the power system, and when it is combined with the sinusoidal nature which is being provided by the source voltage, so obviously the resultant waveform will be like this. It is distorted one, and if that distorted waveform is consumed by load B, so obviously load B will not work properly. So here it is very important to understand that the point of common coupling is nothing but the point of study of interest. So where our linear loads are connected which may affect due to the bad quality of supply. And why we are studying the power quality, and the basic purpose of this subject here is to study the power quality to protect linear load from the bad power quality caused by the nonlinear load. This is our purpose. Obviously A is the polluting load, so we don't care about the polluting load. Our purpose is to block the distortion from the waveform at the point of common coupling and provide the ultimate sinusoidal standard kind of supply to the voltage to the load B here. So this is our purpose for the studying of the power quality. Now these are some contaminations from the power supply are called power quality events. So just like the very previous example, we have studied that contaminations into the water which causes the harms to our body, maybe illness, maybe different kinds of diseases. So here also these are some contaminations from the power system, from the waveform of voltage, or maybe for the current. And these contaminations when supplied to the load, basically linear load, so or non-linear load, maybe any load, so they may get affected. The load may not work properly. So in this particular subject, in unit number 1, we are going to study these types of all power quality events, their definitions and the terms used for the description of them. In same unit, we will cover the power quality standards IEEE 1159 2009, 519 2014. Next point we are going to cover is power quality issues associated with the grounding. Now in going to further detail, we will now have to discuss every power quality event in a detail. So in unit number 2, the voltage sag is covered into the detail with its characteristics, then its when it is present into the system, at that time what will be the behavior of equipment, in its monitoring and the mitigation. Now, unit number 3 will cover the various transients occur into the system and the flickers, their classification, then how it's been produced, their sources, and how they affect into the system, and again some protection methods. And part B contains the flicker source and the mitigation. Now next event, that is the harmonics. So in fourth unit we will cover the fundamentals of harmonics, that is basics of harmonics. Then when harmonics are present into the power system, how they will affect on active power, reactive power and the apparent power. And finally we will study the monitoring and effects of the harmonics. In fifth unit we will cover the concept of point of common coupling in detail, then computer tools for harmonic analysis, design of filter for harmonic reduction. So various filters we require to eliminate the harmonic from the power system. So their design we will cover into the unit number 5th. Now unit number 6th is nothing but the various instrument study to measurement of the power quality problems and various analysis software and the instruments will cover. Now the prerequisites for this particular course are fundamentals of power system and the fundamentals of the power electronics. So we need to know both basic concepts. Next is the teaching scheme for the particular course. That is, it has total 4 credits, 3 credits for theory and 1 credit for the practical. Similarly, it has in-sem examination of 30 marks, in-sem examination of 70 marks and term work marks of 25, which depends on your overall performance into the semester. So this subject basically has total 125 marks. Now let's move towards the course objective. So first objective is to develop ability to identify various power quality issues, then to understand relevant IEEE standards, what exactly the IEEE standards are, and to illustrate various power quality monitoring techniques and instruments, to learn and characterize various power quality problems, to identify different mitigation techniques. Now course objectives are, after completion of this course, student will able to characterize power quality events, reproduce causes of voltage sag and estimate magnitude of voltage sag, and carry out harmonic analysis and calculate total harmonic distortion, and calculate parameters of passive harmonic filter. Now to fulfill these course outcomes, we need to do some practical aspects. We need to check some practical aspects also, and we will cover simultaneously with the theory those some practicals. If it is possible, we can have some simulations on it, some hardwares on it, and some actual measurements on it. So with the combination of that, students will able to perform these outcomes.
Welcome to the e-lecture series on power quality. I am Mr. Somnath Hadpe, Assistant Professor, Electrical Engineering Department from Matosri College of Engineering and Research Center, Nasik. In this Module 1, we will cover power quality definition as per IEEE Standard 1159, and importance of power quality, then symptoms of poor power quality. Let's move towards the power quality definition. Power quality definition is changes according to the various stakeholders of the power quality. Like, first stakeholder is the utility, those produce, transmit and distribute power. So according to utility, power quality as reliability and show statistic demonstrating that its system is 99.98% reliable. For them, power quality is totally a reliability that should, from utility to customer, 99.98% they can deliver. The second stakeholder of the power quality is equipment manufacturer. Now, a manufacturer of load equipment may define power quality as those characteristics of power supply that enables the equipment to work properly. Then, third end is the end user. Now, according to end user, definition may change. That is, for end user customer, his equipment should work properly without any kind of failure. That is enough for the customer. So it is his own definition. But according to IEEE standard 1159, the power quality definition is the concept of powering and grounding sensitive equipment in a manner that is suitable to the operation of that equipment. Means when any sensitive equipment is consuming a power, so we should ensure its grounding so that it could not misbehave or misoperate. So that is the definition for power quality according to IEEE. But in general, we say power quality is nothing but the voltage quality. So if we combine all these definitions, so one common conclusion we can make, that is, any power problem manifests in voltage, current or frequency deviation that results in failure or misoperation of the customer equipment. The next part comes, that is symptoms of poor power quality. Now if this poor power quality, if it is consumed by various equipments in a power system, then what will happen? The first impact is on the insulation. Now insulation has very important role in preventing the leakage current. Now any over voltage will risk in the risk of the insulation failure. Of course, every equipment, it is manufactured by means of understanding some level of the voltage. If that voltage level exceeds then its operating voltage, then obviously it will definitely impact on the insulation of that equipment. Insulation may be internal parts, maybe from its body to the earthing parts, maybe the person working on that equipment. So insulation plays a very vital role to avoid the leakage current. And obviously this holds for the system components such as transformers and cables, as well as for the end user equipment such as the motor, because these particular equipments basically contains a winding structure. In cables there are different conductors are molded in insulation with a very few centimeter gap or gap, and if that insulation is punctured, if it is breakdown, then obviously there is a possibility of a danger. So therefore insulation impact is basically very important because it is a long term effect, and in most cases which is not significant. But when equipments are working normally and if there is a sudden any kind of over voltage, so obviously the base voltage level of that equipment get rises, and which may be the causes of the transient over voltages to start. And of course, due to that, the risk of peak voltage and thus the risk of insulation failure rises. Now in case of induction motors, over voltages will lead to reduced starting torque and increase full load temperature rise. Why? Because in case of induction motor, starting torque is directly proportional to the terminal voltage of the induction motor. And if there is under voltage, so obviously the starting torque of induction motor will reduce. And due to that, there may be possibility that the motor will take more time to accelerate. and in some cases it may possible that it will not move, it will be at the one single position, and that's why may it is at a stall position. Now if we go further for the over voltages, in the same case, just like a previous case, in previous case what happened? Due to under voltage, torque of the induction motor reduces, but in case of over voltages, the reverse effect will be there, that is the torque of induction motor may increase, and due to that it takes more current, and obviously when it takes more current, so of course your power factor will decrease, and the decrease of power factor is nothing but the symptom of a power loss. And so we can say here that due to over voltages there may be a power losses into the motor. Then obviously when equipments are connected to the motor, due to the high starting torque, the equipments get a sudden jerk, and due to that rest of the driving system may get affected. Now here one another interesting thing is that when a motor initially when it has a over voltage, and when motor gets a more current at the starting as its torque is very high, so the equipment which is connected near to the motor or at the same bus bar at the motor, or it may experience the voltage sag. Why? Because the sudden there is a start of the motor and there might be significant voltage drop which may be experienced by the nearby equipment. So these are the some we can say that the effects of the bad power quality. If we move further, in case of induction incandescent lamps, the every particular incandescent lamp or maybe any kind of device, electrical basically devices, they have their limited or one particular standard life of span. If you take example of a switch, so switch when it is made, it is expected that after 1000 operation or 1000 2000 operation, his operations or whatever the switching operation, once they are done, the life of that switch will be over. Likewise that if you take example of an incandescent lamp, so incandescent lamp also designed in such a manner that their on off operations are predefined 1000 times, 2000 times, whatever its lifespan, it is already defined. But due to the poor power quality supply, that particular number of operations, suppose any incandescent lamp is designed for the 1000 operations, on off operations, but due to the poor power quality, what will happen? That number of operations may reduce, because it will count those fluctuation in a power are also at its their on and off positions, so that may happen. So this is one we can say that the impact on an incandescent lamp. In case of fluorescent lamp, the light output of lamp is directly proportional to the applied voltage, and if applied voltage changes, obviously its output will change. The lifetime of fluorescent lamp is affected less by voltage variation than that of the incandescent lamp. The resistance heating devices are also affected by means of a poor power quality, because the energy input and therefore the heat output of resistance heaters vary approximately at the square of the voltage. Means the relation here, it is directly proportional to the square of the voltage of the heat output. Here one example is discussed, that is 10% drop in voltage will cause the drop of approximately 20% in the heat output. So that much effect is there on the resistance heating devices. Now resistance heating devices are the devices where we require the temperature rising conditions by means of a electrical energy. And under voltage will lead to increase the duty cycle of any equipment that uses the thermostat, heating, refrigerating or air conditioning. Now obviously duty cycle is what? It is the if you take the example of the heating device, that is geyser, electric geyser you are using in your house. So In that particular electric geyser, there is one bimetallic switch which operates when a water temperature rises at a particular level. Suppose we consider it as a 80 degrees Celsius or 70 degrees Celsius. So when the temperature reach at that particular level, it operates and automatically turn off the electric geyser. Now this is the duty cycle of, we can say, that particular geyser, that is on and off condition. Now due to the under voltage, what happen? These duty cycles may get vary, and due to that the lifespan of that equipment is decreases. The result is that the total current for the group of such devices will increase, and if devices are used in a group, so obviously everybody takes a more current due to the under voltage. Even though individual heaters behaves as a constant resistance load, a group of them behaves as a constant power load. Now let's discuss the impact on electronic equipment. So of course every electronic equipment required a very precise kind of electric supply, and if it will not get that one, so obviously it will not give the proper output. Every electronic equipment is very less efficient for the under voltages, and of course it will be more sensitive for the voltage dips. If we take the example of various equipments, those require a constant DC supply. That constant DC supply, it's been derived from the constant AC supply through the step down transformer. But if the transformer is not getting a proper supply, so obviously it will not give at the output a constant step down supply, and that may be not converted properly to give the supply for the electronic equipment. A higher than nominal voltage will take the equipment more sensitive to over voltages. Very important equipment from power system is a transformer, and now transformer also get affected by the poor power quality. And another reverse effect is that due to that poor power quality, transformer also contribute into the affecting the power quality. So when the transformer get a higher voltage than that of its nominal voltage, so obviously it increases the magnetizing current of the transformer, and as the magnetizing current is heavily distorted, there is an increase in voltage magnitude which increases the waveform distortion. That means due to the higher voltage, magnetizing current will rise, and due to the rise in magnetization current, it again rises the output voltage level, and which again causes the over voltage into the system height. So that is the contribution of a transformer. Summary of module 1. So in this module 1, we understand the power quality, then characteristics of good power quality, different stakeholders of the power quality, and importance of power quality, and symptoms of the power quality. So students, after completion of module 1, you have to do this assignment for the understanding purpose, that define power quality according to IEEE standard 1159, then what is need to study power quality, and explain symptoms of poor power quality on various electrical equipments. For any kind of queries, you can write to hadpe.somnath@gmail.com, so that we could understand your problems and can give you the feedback. Thank you very much. Thank you.